Good day. You're welcome to today's class. In our today's class, we will look at a question from IGCSE past questions, and it says, in the triangle, using sine 15 degree as root 2 over 4 bracket open root 3 minus 1, and without calculator, find the value of sine theta in the form a plus b root 2, where a and b are integers. Solution. For us to get this done, we will apply the sine rule. The sine rule says small a over sine A is equals to small b over sine B, which says equals to small c over sine C. So doing that, we have 4 root 3 plus 4 over sine theta is equals to 3 root 2 plus 4 over sine 15. So making sine theta the subject of the formula, we have 4 root 3 plus 4 in bracket multiplied by sine 15 degree all over 3 root 2 plus 4. Substituting the value of sine 15 degree given, we have 4 root 3 plus 4 in bracket multiply root 2 over 4 bracket open root 3 minus 1 bracket closed all over 3 root 2 plus 4. So we have to multiply. So we have root 2 over 4 multiply root 3 to give us root 6 over 4, and root 2 over 4 multiply minus 1 to give us minus root 2 over 4. So we have 4 root 3 multiply root 6 over 4, it gives us 3 root 2. And 4 root 3 multiply minus root 2 over 4, it gives us minus root 6. And we have 4 multiply root 6 over 4, it gives us plus root 6. And we have 4 multiply minus root 2 over 4, it gives us minus root 2. All over 3 root 2 plus 4. So we rationalize the denominator by multiplying 2 root 2 over 3 root 2 plus 4 by 1. Having the conjugate of the denominator 3 root 2 plus 4 as 3 root 2 minus 4. So if you watch there in the bracket, you have 3 root 2 minus 4 divided by 3 root 2 minus 4, which is just 1. Multiplying any number by 1 remains the same. So in that case, if we open the bracket, this bracket, we will have 12 minus 8 root 2 all over 18 minus 16. When you multiply two conjugate surds, it ceases to be a surd, rather it becomes a constant. So we have 12 minus 8 root 2 all over 2. So that gives us 6 minus 4 root 2. So the integers are a equals 6 and b equals minus 4. Alright, the second question there says, the vertices of a trapezium ABCD are the points A minus 5, 4, B 8, 4, C 6, 8, and D not given. The lines AB is parallel to the line DC. The lines AD and BC are extended to meet at E, and angle AEB equals 90 degrees. Roman figure 1, find the coordinates of D and of E. Roman figure 2, find the area of the trapezium ABCD. Okay, here comes the solution. In the solution, we try to say, let the coordinates of D be A, B, and E be R, Q. And let the gradient of line AB equals M1, and the gradient of line BC, which is equals to M2, that is the same as BE. And we also have the gradient of line AE equals M3. Now lines AB parallel to DC, the gradient M1 for both lines will be the same. Using the coordinates as given, A as minus 5, 4, B 8, 4, and C 6, 8, and D A, B, and E R, Q. So from the gradient of line AB, which is 4 minus 4 all over 8 plus 5, should be equal to the gradient of DC, which is B minus 8 all over A minus 6. So 4 minus 4 is 0. 0 divided 13 is 0. So we have B minus 8 is equals to 0. So the point B is 8. The gradient of BC is equals to BE as collinear points. So we have 8 minus 4 all over 6 minus 8, which is the gradient of the line BC, is equals to 4 over minus 2, which is minus 2. So the gradient of the line BC, which is M2, is equals to minus 2. Since the line AE is perpendicular to BE, let the gradient of AE be equals to M3. So M3 times M2 is equals to minus 1. Therefore, M3 is equals to half. Having the points A, D, and E as collinear points, the gradient of the line AD, which is B minus 4 all over A plus 5, should be equal to the gradient of the line AE, which is Q minus 4 all over R plus 5, should be equals to half. Taking the first and the last, comparing the two, we have B minus 4 all over A plus 5 is equals to half. So substituting the value of B as 8, we have 8 minus 4 all over A plus 5 as half. So 4 all over A plus 5 as half. So A plus 5 is equals to 8 after cross multiplying. So A is equals to 8 minus 5. So A is equals to 3. So the coordinate of the point D is 3, 8. From the same equation, we have already that R minus 4 all over R plus 5 is equals to half. So we have, from there, we have R plus 5 is equals to 2Q minus 8. So R minus 2Q is equals to minus 13. That's equation 1. Secondly, the gradient of the line BE is equals to minus 2, which is Q minus 4 all over R minus 8. So Q minus 4 is equals to minus 2 into R minus 8. So Q minus 4 is equals to minus 2R plus 16. So 2R plus Q is equals to 20. That's equation 2. Substituting equation 1 in equation 2, we have 2 into 2Q minus 13, bracket closes, plus Q is equals to 20. So 4Q plus Q is 5Q minus 26 is equals to 20. So 5Q is equals to 46. So Q is equals to 9.2. Having gotten Q as 9.2, let's find R. R is given as 2Q minus 13, which is 2 times 9.2 minus 13, which is 18.4 minus 13. So R is 5.4. So the point E is 5.4, 9.2. Now, area of the trapezium is equal to area of triangle ABE minus area of triangle DCE. So the area of triangle ABE using Lewis method determinant, we have plus or minus half of 111 x1, x2, x3, y1, y2, y3. So substituting the coordinates using Lewis method for finding 3 by 3 matrix determinant, taking the major diagonals first, we have 73.6 plus 21.6 minus 20 minus bracket open. Now taking the minor diagonal, we have minus 46 plus 21.6 plus 32. So evaluating that, you have 75.2 minus 7.6. That gives us 67.8 multiplied by half, positive half. That gives us 33.9 squared unit. Now the area of the triangle DCE using the same method gives us 1.8 squared units. Therefore, area of the trapezium is equal to 33.9 minus 1.8. That is 32.1 squared unit. Thank you for participating in today's class. I remain my humble self, Mr. KK Emmanuel Okemde. If you wish to hear from us, you can reach us through the phone number 080-387-46884. Please do well to share our video if you come across it. Sharing the video is an encouragement. If you have any question, we will be glad to see it on the comment section. God bless you.